Good morning, or almost. Have a nice lunch. I think the three questions my name is Franz Ulm, I come from MIT. The three questions which we need to address when we talk about sustainability is: where are we, where do we need to be, and how do we get there? I think my colleague from Auburn just described well where we are. 3-year-old soccer game coming from Europe, I know what that means. Where do we need to be is, let's say, to push the envelope further. How do we get there is to get quantitative. Sustainability is not just something to feel good about yourself, feeling good. You need to be quantitative. That is the role of engineers. And with all my respect to politicians, the main difference between engineers and politicians is we need to come up with numbers, not just feelings. How to quantify sustainability, and that's what I would like to address very briefly. We have already heard this here. Where are we? Why are we interested in performance on the rolling resistance? In addition to air drag, internal friction related to the motor, we have rolling resistance, and there PVI enters the picture. And we have heard from our colleague from trucking industry how important that rolling resistance is. Pavement texture, absolutely critical for safety. We have heard that here, a critical element. Roughness and smoothness, another one, and then deflection, dissipation, induced PVIs add up. The question is, how much? Let's make clear, what are the two quantities? If we want to become quantitative, we have to go down the weeds and look what takes off the energy of our system. Why do we need to provide extra energy to the system? Well, when it comes to roughness, it is the reason that we like a comfortable ride, because we have suspension system in our vehicles. If we did not have suspension system in our vehicles, having a tough ride, we would not consume extra energy. The same thing, by the way, is now when you go to the deflection part of it. In fact, it is basically the suspension system of our pavement, which is the dissipation of energy. And in fact, that goes back to a colleague from Caltech University, Professor Flügge, in 1975, actually had this picture there in his book, where he showed basically that because of this type of suspension system of our pavements, we have an extra fuel consumption. The wheel is always on a slight uphill slope. Well, why does it matter? Well, it does matter actually, as we have heard, and that's a very important point about it. How can we quantify that here? We have today the means of quantifying it. First of all, please note, you don't need to know all these Greek letters, by the way, but one thing which I would like to point your attention to is the first one. P is the load. So if you go from a normal vehicle to a truck, so from a couple of tons to 40 tons, you really see that here the weight of the vehicle scales with the power 2, requiring more energy. This is why it becomes so important for the trucking industry, and less so for our normal vehicles. The second one is C, is the speed. We saw it before with S. Actually very interesting. As the speed goes down, actually you have a higher dissipation. You need more energy, which means for intercity roads, it definitely increases. So that is an extra fuel consumption. Thirdly, temperature matters. The hotter it is, and you see this here now, I didn't took Florida weather because I didn't want to shock you there, so I took Minnesota. But you know, you just be aware that you have about 1 liter per 100 kilometer excess fuel consumption somewhere in Minnesota in July. I'll let you judge how much that is for Florida. Well, concrete has also a similar type of behavior, but it's much less so because it's less temperature resistant. But why does all that come together, actually? And I think that's my key message here, which I would leave you with here. Because on average, if you count it, you can come up to numbers between 6,000 and 7,000 gallons per lane mile in year. And we're going to debate for another 10 years whether it's 6,248 or 6,750. The number, order of magnitude, will stay. The question actually was raised by my daughter when she asked, what's the mileage of our pavement system? I said, I know the one of our car, but I don't know what I get out of our pavement system. And that's sort of the number, 6,000 to 8,000 gallons per lane mile in year. So if I take just the 43,312 lane miles all roads of Florida, which are found on the internet, you're talking about 1.5 million tons of CO2 per year. So if you wanted to offset that here with having a clear vision of quantitative sustainability, you would need to plant per year 1.5 million trees in Florida and let them grow for 100 years. So these are substantial numbers. And we can be quantitative. That is what engineering is about. And it's not a matter about concrete versus asphalt. That's about caring about our communities. Here I show you some data for the entire United States where you actually realize that the one where most savings can be done are in other principal arterials. Now, if you bring that back to the financing models, think about it, where are the most renovations or rehabs being done in our country. So what I want to bring forward to this discussion is we need to be quantitative. We need to be quantitative when it comes to sustainability. It's not just about feeling good. Yes, we want to feel good about ourselves. Quantitative means here, in the end, come up with a number where you can compare one solution with the other one and make our system more sustainable. Quantitative sustainability has to do with performance. And that performance here relates to material parameters, to vehicle parameters, parameters we can modify. It's not God-given. This is something human can influence. So let's do it, and I hope for Florida. Thank you.
We have about 15 minutes for questions, if we have any from the audience.